So we said earlier in the previous videos that the order of a reaction is not determined by the stoichiometry or the number of moles of the reactants or products. So for us to determine the power to which each reactant concentrations are raised in the rate law, we need to determine by experiment. And one common method for experimentally determining the form of the rate law for a reaction is the method of initial rate. So the idea is to determine the instantaneous rate before the initial concentrations of reactants change significantly. So let's look at the question 1 here. So consider the hypothetical reaction in which B plus C gives D. So the following data were obtained from 3 experiments. So here is the data for experiment 1, the data for experiment 2, data for experiment 3. So first of all, write the rate law. We can say that the rate equals to what? K in the bracket P. So the order of the reaction with respect to the concentration of B, let's call it X. And the order of reaction with respect to concentration of C, we call it Y. So first, let's solve for X first. For us to solve for X, we must look for the concentration of C that are constant. We have to look at the experiment and choose 2 experiments in which the concentration of C are constant, because that will make them cancel out, and therefore we'll be able to solve for our X. So looking at experiment 2 and experiment 3, concentration of C are constant. So we can therefore say that experiment 2, we have that 1.4 times 10 raised to power minus 2 equals to what? K in the bracket 0.30 X, and so we have 0.15 Y. So experiment 3, we also have that 0.0 times 10 raised to power minus 3 equals to 4 K, concentration to be 1.5 X, and concentration to be 0.15 Y. So because the concentration of this and these are constant, they cancel out. So K also cancels out. So we divide equation 2 by equation 3. So therefore we should have 14 times 10 raised to power minus 3 over 70 over 7.0 times 10 raised to power minus 3. So we therefore have that let's call this 30 over 15. So everything raised to power X. So we can therefore say that this cancels out. So we have 2 here. So we have 2, and also this cancels out. We have 2x. So anything raised to power 1 is t itself. So 2 raised to power 1 will still give us 2. So we can therefore evaluate the power to give that x equals to 1. So the order of the reactant B with respect to the rate of the reaction with respect to the concentration of B is 1. So the order here is 1. So let's solve for Y as well. So for us to solve for Y, we must look for 2 concentration or 2 experiments in which the concentration of B are constant. So equation 1 and 3 have the same concentration of B. So therefore we have that equation 1 is 3.5 times 10 raised to power minus 3 equals to what? K 0.15 X and 0.075 Y. So we also have the other one, equation 3, to be 7 times 10 raised to power minus 3 equals to K 0.15 X 0.15 Y. So we have this cancels out. So this one becomes 1, this one becomes 2, right? So this one cancels out, this one cancels out. So this one becomes 1 and this one becomes 2. So we are left with 1 over 2 equals to what? We are equals to 1 over 2, everything raised to power Y. So we have that 2 raised to power minus 1 equals to 2 raised to power minus y. So when you evaluate the power, we have that y equals to 1. So we can therefore write the rates law as r equals to what? K b raised to power 1 and c raised to power 1. So let's solve for this question too. We have this equation here. So the rate of formation of C in the above reaction is found experimentally to be independent of the concentration of B and to quadruple when the concentration of A is doubled. So what is the rate law for the reaction? So let's solve for this. We have that the rate law R equals to we can see that 1 over 3 D change in concentration of A. Remember that we're working with the reactants only, so we'll say negative 1 over 1 change in B over the T can be written to be K. So we have A. So this has to be determined by experiment. We don't just say 3 and put 3 here, no. So we put X, we need to determine it. So we have our B as well, Y. So the next thing we need to do, we need to read the expression in the question. So we're told that the rate of the reaction is independent of the concentration of B. So therefore we have that R equals to K. We have A X independent of B. So this is 0. N raised to power 0 is the same thing as 1. So that is the first expression there. So the second expression says that the rate of the reaction quadrupled, that is, it increased by 4 when the concentration of A is doubled. So we have K to be, when the concentration of A is doubled, K, the rate of the reaction increased by a factor of 4. So we have B to still be constant. So we have to, so divide equation, let's divide equation 2 by 1. So we therefore have that 4R over R equals to what? This one cancels out already. So we have 2x AX over AX. And so this one also cancels out. So we have R cancels out. We have A cancel A. So we therefore have that 4 is the same thing as 2 raised to power 2. And we have 2x here. So when we evaluate the power, we have that x equals to 2. So this is the final answer. We can therefore say that the rate equals to what? K raised to power into bracket of A raised to power 2 and this to be 0. So the overall order of the reaction is 2 plus 0 and that's 2. So I hope you got it. Thank you.